In this video, we're going to be talking about regions, and you can use shading on graphs to identify regions that satisfy linear and quadratic inequalities. So if we have something like y is less than a function of x, then this represents the points on the coordinate grid below the y equals f of x line, okay? And we're going to look at that in just a moment, but just keep those facts in mind for the second. And if we have something like y, an inequality where y is greater than a function of x, then this represents the points on the coordinate grid above the line y equals f of x, okay? So let's have a look at that on a graph. So if I drew some coordinate axes down here, so we've got a y and an x, and let's just label those appropriately, okay? And I was to draw a region like this, okay? So this is our line, this is our function, and I'm going to just shade in the part above the line, okay? Now, all the shaded points here in this region satisfy the inequality y is greater than f of x, okay? That's that region there because it is above the y equals fx line. Whereas all these points down here below the line satisfy this top inequality, y is less than f of x, because all of these points are below the line y equals f of x. Now, the other question is, why did I use a dotted line here, okay? So this satisfies situations where it's less than or greater than, okay? Now, if we have these two, if we have y is less than f of x, or y is greater than f of x, then the curve y equals fx, like we have on here, will not be included in the region, okay? Because obviously it's not greater than or equal to or less than or equal to, so it's everything above and everything below. And so as it's not in the region, it is represented by a dotted line, okay? Like such. However, if we had separately y is less than or equal to f of x, or y is greater than or equal to f of x, then in those situations, the curve y equals fx is included in the region and is represented by a solid line like that, okay? So if it's in the region, it's a solid line. If it's not in the region, it's a dotted line. Okay, so let's look at an example. Let's get rid of this. Okay, so let's say we want to shade the region that satisfies the following inequality. Y is greater than and equal to -2, okay? X is less than 5. We're going to have y is less than or equal to 3x plus 2, and x is greater than 0, okay? So we're going to create now a graph which satisfies this particular inequality. Okay, so if I had a coordinate grid, so let's just draw a quick grid now. So we're going to have a y-axis like so, and we're going to have an x-axis that comes across like here, and let's label that like such. And then I'm going to just label the x-axis, so we're going to have -1, -2, -3, 1, 2, 3, 5, 6, 7, 8. And we're also going to have a y coordinate, so we're going to do 5, 10, 15, 20, 25, okay? And so the first thing that we want to do is draw the easiest one. So x is greater than 0 is a pretty easy one, and because it's greater than, because we're looking at a greater than symbol, we know that we got to use a dotted line, okay, because it's not included within the region itself, okay. So we're going to have a dotted line for where x is greater than 0, and x is greater than 0 on this point here in the middle. So it's a bit difficult to write because it's actually on the line itself, but it would be like such. Okay, so we've got a dotted line where x is equal to 0, and we're also going to have a dotted line where x is less than 5, okay, because we've also got a less than symbol. So it's not less than and equal to, it's just less than, so it's not included within the region. It's also a good idea actually to put, you know, where you've put the dotted line. So here I've put x equals 0, also so that you don't actually forget what you're doing. Then x is less than 5, so we've got 5 down here. So I'm just going to label this as well as x equals 5. So we've got a dotted line. And if you want to as well, you can always just cross off the relevant things that you've done. Okay, and we also need to draw lines for y is greater than or equal to minus 2. Now, because it's greater than or equal to, it's going to be a solid line because obviously it's included within the region itself. So that's going to be down here. So we've got minus 2 on the y-axis, and it's going to be a solid line like such. And finally, we want to look at y is less than or equal to 3x plus 2. So we know that y equals 3x plus 2 is just going to be just a linear equation. So if we just plugged in a couple of numbers, we're going to get 2 points, and we can just draw a straight line through them. So if x is equal 0, then y is going to equal 2. And if we had x is equal to 2, then we know that y is going to equal 8, okay? And we can just plug those points in to here. So we can have 0 on the x and then 2 up here. And we've also got 2, 8 up here. So we're going to get a line that looks a little bit like, well, let's first of all check what it's got to be. Well, we know it's got to be a straight line, like a solid line, because we've got is less than or equal to. So we're just going to draw a straight line that goes straight through these points. And it would also be a good idea to label this point too, ideally up here at the top. So this is y equals 3x plus 2. Okay, so now we want to shade the required region, okay? And obviously, this can be a bit tricky, but as long as you just sort of pay attention to what you're doing, you should be absolutely fine, okay? And the way to do this would be to shade the region that you think is correct, well, you know, do it correctly, and then use a test point in the region to make sure it does satisfy the relevant region. So we want it to be greater than 0 and less than 5, so it's got to be within this region here. And we know that it's got to be greater than or equal to minus 2, so it's got to be within this region here. And it's also got to be less than 3x plus 2, less than or equal to 3x plus 2. So it's sort of this almost triangular shape in here. And so if we just shade this in, this would be the region that satisfies all of these inequalities at the top here. And to make sure you've got the correct answer, we can now use a test point within the region. So let's try the point 1, 2, okay? So if x equals 1, it's got to satisfy everything at the top here. So is 1 less than 5? That's true. Is 1 greater than 0? That is also true. Okay, good. So the x points seem to satisfy these inequalities. How about the y? So is 2 greater than or equal to minus 2? Well, yes, it is. And is 2 less than 3 plus 2? Okay. And yes, that is true as well, because if we plug in the x here, we got 3 plus 2, which makes 5, so it's 2 less than 5, yes, okay? So it seems that our test point here does satisfy a point within the region. I was going to show another example using a quadratic inequality, but I think you get the point, to be honest. But if you do have any issues with solving these for quadratic inequalities and looking at regions within quadratic inequalities, leave a comment below and I will create a video as soon as I can. But if you have any other questions about this video or any other video, then let me know and I will reply. And yeah, make sure you subscribe to my channel and give this a thumbs up. Thank you very much for watching.